Hey guys, today is day 25 and we're going to talk about parallel and perpendicular lines. Okay, so in the last two units, we've been talking a lot about linear equations. And linear equations, we typically put them in slope-intercept form, y equals mx plus b. And remember that the m is the slope and the b is always the y-intercept, okay? So we need to really remember that. All right. So we're going to look at the first two equations that we have. All right. We have two lines that are there, and we need to come up with equations of the lines. So I'm going to look at line A first. And I like to first identify the y-intercept, where that line crosses the y-axis. In this case, the y-intercept is 6. Okay. I then like to identify another point where it is crossing a whole number ordered pair. So I'm going to look at that point right there. And from that, I'm going to determine the slope by doing my rise over my run. So my slope is 2, I go up 2 and to the right 1. So my slope is 2 over 1, which is 2. Okay, so once I have the slope and the y-intercept, I can easily write the equation of the line. All right, again, y equals mx plus b. All I have to do is plug in the m and the b, and I have y is equal to 2x plus 6. All right, now we look at the second line, line B, okay, and these are snapshots. Remember, these lines go on and on forever, so I'm just going to add the little arrows in. So line B, again, I like to start at my y-intercept. In this case, my y-intercept is -4, and I'm going to calculate my slope. I'm going to use the point right here, so I'm going to rise 2, and I'm going to run 1, so 2 over 1, again, is 2. So I put it into slope-intercept form, and I have y is equal to 2x minus 4. Okay, so there are my two lines with my two equations. Now let's look at the next example. All right, now I have horizontal lines. This is our special case, and we like to think of HOI for horizontal. It means the equation of the line starts with y equals. Okay, in this case, line A, y is equal to, and we look at where it's crossing the y-axis, it's just equal to 3. All right, and I look at line B, and it's actually crossing at -2, so y is -2. All right, and keep in mind that both of those lines have a slope of 0. That's what the O in HOI helps us remember, okay? Or the video that we watched, this is Zero Fun, okay? So they both have a slope of 0. All right, now let's look at the third example here. Again, I'm going to add my little arrows, okay? These, just looking at them both, they're negative slopes, okay? We're going down, okay? Remember, because slopes always read from left to right, so we're going down. But let's start with line A and have our y-intercept. So the y-intercept for line A is right here at -4, okay? And the slope for this, if we go up one, we'll use this point right here, we're just going to go up 1 to the left 1. So that means our slope is 1 over -1, which is a -1 slope. So the equation of that line would be y is equal to -1x, or just, I like to write just -x minus 4. All right, now looking at line B, identifying the y-intercept, we've got y-intercept is 3, and the slope here, all right, we're going to go down 1 to the right 1, so it's a -1. Okay, so our slope here is -1, so the equation is y is equal to -x plus 3. All right, so in all three examples, if you notice the slope of all of these parallel lines, they're the same. We have 2 and 2. In the second example, they're both a slope of 0. And the third example, they're both a slope of -1. Okay, think of -1. So what do you notice about the slopes of parallel lines? They are the same. All right, and remember, parallel are two lines that go on and on and on forever and never cross. So that would make sense that they would have the same slope. Okay, so let's now look at what perpendicular lines are. So perpendicular lines, if you think of them, I like to look straight on. All right, they're just going to cross right at a 90-degree angle. Okay, sometimes they're shifted. Okay, so it says each graph contains perpendicular lines. We're going to write the equation for each line in the space provided. So again, just like the last example, I'm going to look at first line A. Okay, here's my line A. And when I start with line A, my y-intercept is right here at 1. And my slope is, we're going to rise 2 and run 1, so my slope is 2. So the equation of that line, line A, would be y equals 2x plus 1. Again, you just need your slope and your y-intercept, and you can come write the equation of the line. Now line B, all right, if I look at line B, we're actually crossing here at let's do it right there. There it is. Okay, our y-intercept is 0, and our slope, we're going to go down 1 and to the right 2. So I'm going to go down 1 to the right 2. So I've got a negative 1/2 slope. So notice our slopes are different with perpendicular lines. Y equals negative 1/2 x plus 0, but I'm just going to say just negative 1/2 x. All right, so keep that in mind. We're going to move on to the second example. All right, so for line A, when we look at line A, we've got, let's see, our y-intercept. Let's start with this one right here, line A. Our B is going to be negative 4, okay? And then our slope is going to be, let's see, we're going to go over to this point here. So we're going to go up 1, 2, 3 over 1. So our slope is 3, okay? So the equation of that line is going to be y is equal to 3x minus 4. Now when I look at line B, my y-intercept here is at 0. And my slope, I'm going to go down 1 and to the right 1, 2, 3. Okay, so I go down 1 to the right 3. So it's a negative 1/3. So the equation of that line is y is equal to negative 1/3 x. Okay. All right, so now I look at the third example, and we've got line A. My y-intercept right here is crossing at 3, so my B is 3, and my slope is going to be, I'm going to go, let's use this 1, 2, 3, 4 over 1. So it's actually go down 4 and to the right 1, so my slope is a negative 4. So the equation of the line is y is equal to negative 4x plus 3. All right, and then this bottom one, our y-intercept is right here at negative 3. And our slope is, we're going to go up 1 to the right, 1, 2, 3. We're going to use this point. So up 1 over 4. So our slope is 1/4. So when I write the equation of that line, it's y is equal to 1/4 x minus 3. All right, so what do we notice about the slopes of all of these? Okay, so the first example, we had a slope of 2 and we had a slope of negative 1/2. The second example, we had a slope of 3 and we had a slope of negative 1/3. And the fourth one, we had a slope of negative 4 and a slope of positive 1/4. Okay, so what we notice about the slopes of perpendicular lines is that they are the negative reciprocals or the opposite reciprocals. Opposite reciprocals. Okay, and what I mean by a reciprocal, I like to think of a reciprocal, or you're flipping it. So 2/3, the reciprocal would be 3/2. 4 would be 4 over 1, you'd flip it and get 1 over 4. So that's how we'd get a reciprocal. And the opposite means if one is positive, the other one is negative. So to get a perpendicular lines, you have to have the opposite or the negative reciprocal slopes. Okay, so we're going to use those two concepts, all right? It says if two non-vertical lines have the same slope, then they are parallel. And we use the notation two little parallel lines to mean parallel, okay? So if I had y is equal to 2x plus 3, all right, say this was line A and this was line B, y is equal to 2x minus 1, I could say that line A is parallel to line B. Okay? Now with perpendicular lines, so if two non-vertical lines have slopes that are negative reciprocals or opposite reciprocals, okay, then they are perpendicular. And the symbol we use for perpendicular looks like an upside down T. All right, so if I had line A being y is equal to 3x minus 2, and line B maybe was y is equal to negative 1/3 x plus 6, we could say that line A is perpendicular to line B. Okay, or you could say it the other way around too. Line B is perpendicular to A, because if we notice the slope here is 3, and then we have negative 1/3. So they're the opposite or negative reciprocals. Okay, so keep that in mind. Parallel, same slopes, perpendicular, opposite reciprocals. So write an equation of the line that passes through -3, -5, and is parallel. This is a key word. That tells me it needs to have the same slope as this line, because we're writing the line that is parallel to this line, and it has to go through the point -3, 5. So what I'm going to do is just pull out the slope here of 3, okay? But a parallel slope is the same thing. That's also 3. So I'm going to use that slope 3, okay, the parallel one, which happens to be the same, with this other point. And I'm going to use point slope form that we did in our last unit. Y minus y of 1 is equal to m times x minus x of 1. And I'm just going to plug it in just like we did last unit. Okay, so this would be y minus a -5 is y plus 5 is equal to 3 times x minus a -3 is x plus 3. Okay, so I just plugged it in, and now I distribute it. All right, and now I'm going to subtract 5 from both sides. So my final answer is in slope-intercept form. It's 3x plus 4. Okay, and what can happen here is if I put this equation into Desmos and this equation into Desmos, you're going to see that these two lines are parallel, and they'll go on and on forever and never cross. They both have the same slope. All right, so we're going to try another example with this. Okay, write an equation of the line that passes through this point, okay, and is parallel. There's our key word. So that tells me I get my slope here. My slope here is a -1. Parallel means they're the same, so the same slope is also -1. I'm going to use that new slope with the point. So y minus y of 1 is equal to m times x minus x of 1. So we're going to say y, don't forget this is your x and your y, x1, y1. So y minus 11 is equal to our slope, which is -1, times x, and it's going to be plus 2 because we're subtracting a negative. All right, we're going to distribute y minus 11 equals -x minus 2, and then we're going to add 11 to both sides. Y is equal to -x plus 9. Okay, there's the equation of our line. So our final equations, most of the time we just put them into slope-intercept form. That's what you're going to find, the default. All right, so we did 2 parallel examples. Now let's try a perpendicular example. This gets a little bit trickier. Okay, we're writing an equation of line that passes through 4, -5 and is perpendicular to y equals 2x plus 3. All right, so since it's perpendicular, the first thing I do is identify the slope, but now I want a perpendicular slope. So the perpendicular slope is the negative reciprocal, so it's going to be a -1/2, okay, or the opposite reciprocal. All right, I'm going to use this new slope, and this is really important. I have to use this new slope when I do point slope form. All right, so m times x minus x of 1. So we have this new point, 4 minus -5. We're going to plug it in. It's y plus 5 is equal to -1/2 times x minus 4. Okay, so that's important that you know how we set that up. Now we distribute. Y plus 5 is -1/2 x, and 1/2 times 4 is 2, so this is going to be plus 2. And then when we subtract our 5 from both sides, y is equal to -1/2 x minus 3. Okay, so there's our equation. This would probably be a really good time to pause the video and try the next one. Okay, so the next one's very similar to number 3, except, okay, so we're writing the equation of the line that passes through 4, 3 and is perpendicular, keyword, to y equals 4x minus 7. Now these two examples are kind of easy in that they're already in slope-intercept form. If your equation was not in slope-intercept form, you would have to put it into slope-intercept form to first get the slope of the original line. Okay, this one's already given to us. Our slope is 4. From there, we figure out the perpendicular slope, which is the opposite, the -1/4, negative reciprocal. We use that new slope with point slope form. All right, and we plug in the values. So y minus 3 is equal to -1/4 times x minus 4. All right, we distribute. Y minus 3 equals -1/4 x plus 1. And then we add 3 to both sides. Y is equal to -1/4 x plus 4. There's the equation. So if you took both of those equations and graphed them both in Desmos, you would see that they were perpendicular. Okay? All right, so another type of question might be. Determine which lines in each set, if any, are parallel or perpendicular. So the key to this is to find the slope. Okay, find m for each one of these lines. The first one's easy. M is 5. The second one we need to put into slope-intercept form, so we're going to subtract x from both sides. 5y is equal to negative x plus 2, and then we divide by 5. Okay, y is equal to negative 1/5 x plus 2/5. Okay, from here we can determine our slope is negative 1/5 for line B. All right, line C, when we divide by negative 10, we get y is equal to negative 1/5 x after we simplify. So here our slope is also negative 1/5. Okay, so for the first example, we can say, and there's not much room here, I apologize, we can say that line B and C have the same slope, so line B is parallel to line C. They have the same slope. Okay, now if you notice though, line A is actually perpendicular to both B and C. Line B and C. Okay, so again, we didn't have that much room there, I apologize, but the key to these types of problems is just pulling out the slope. So here we had a slope of 5, here we had a slope of negative 1/5, and another negative 1/5. B and C are the same slope, they're parallel, and A is the negative or opposite reciprocal of B and C, so it's perpendicular to both of them. All right, so let's try it again with number 6. Here we're going to pull out our slope. All right, our slope is 3/5. All right, that was easy. It's already in slope-intercept form. B, we have to divide by 5. All right, y is equal to 3/5 x minus 2/5. So here we can figure out the slope is 3/5. So notice they're both the same, so already we can say A and B are parallel. All right, let's look at C. We're going to subtract 10x from both sides, and we get negative 6y. Oops, my pen had died. Why did my pen die? Okay, there it is, negative 6y equals negative 10x minus 4, and then we divide by negative 6. Y is equal to positive 5/3 x after I simplify plus 2/3. So here our slope is 5/3. Okay, 5/3 is the reciprocal of 3/5, but it's not the negative reciprocal or the opposite reciprocal. Okay, so the only conclusion we can make for number 6 is that line A is parallel to line B. Okay, all right, so looking at number 7, we have a question like this. What is the slope of the line parallel to this equation? Okay, what you're going to have to do is first figure out the slope of that equation, okay, and you need to put it into slope-intercept form. So we do this a lot. All right, we're solving for y. Negative 3y equals negative 3x plus 12. We divide by negative 3. Y is equal to x minus 4. Once we have it in that form, okay, it's easy to see that our slope is 1. Okay, and since it's parallel, it's going to be the same. So the slope is going to be 1. Okay, number 8, though, is looking for one that's perpendicular. Again, we've got to put it into slope-intercept form. So I'm going to start by adding my x to both sides. Negative 10y equals x plus 20. And then I divide by negative 10. So y is equal to negative 1/10 x minus 2. So my slope is negative 1/10, but my perpendicular slope is the negative reciprocal. So when I flip it, I get 10 over 1, and it's the opposite, so it's going to be, whoops, it's going to be 10. That does not look like 10. All right, it's going to be 10. Okay? All right, so now let's try to graph a few of these to see what they look like. All right, it says graph each line and then write the final equation in each line in slope-intercept form. So what line is parallel to y equals 3x plus 1 and passes through negative 1, 2? Okay, well, let's start just by graphing 3x plus 1. I start at my y-intercept of 1. I go up 3, 1, 2, 3, and over 1. Or I could go down 3 and to the left 1. So there's my first line. My given line is right there. Okay? All right, and what we're looking for is the line that's parallel and passes through -1, 2. So it's going to go through this point right there. Well, it's easy enough to draw it, but we want to get the actual equation. So what we're going to do is we're going to determine the slope here is 3. The parallel slope is also 3. We're going to use that slope with the point, y minus y of 1 equals m times x minus x of 1. So y minus 2 is equal to 3 times x plus 1, because we're subtracting a negative. We distribute it. Y minus 2 equals 3x plus 3. And then when we add 2 to both sides, we get y is equal to 3x plus 5. Okay? So when I graph this, you can see my y-intercept is 5. 1, 2, 3, 4, 5. And what happens is I'm making a line that's parallel to it, and it works out. Okay? There we go. All right, so we have both lines and we have the equation. Now we'll do an example of perpendicular. Okay, what line is perpendicular to y equals 2/3 x minus 1 and passes through the point -2, 2? So I'm going to start by graphing this line. All right, I start at my y-intercept of -1. My slope is 2/3, so I'm going to rise 2 and I'm going to run 3. Okay, or I'm going to go down 2 and to the left 3, and I'm going to make my line. Okay, so my slope here is 2/3. Okay, but we need it perpendicular. So the perpendicular slope is actually -3/2. I'm going to use that new slope with this point. Y minus y of 1 is equal to m times x minus x of 1. So this would be y minus 2 is equal to -3/2 times x plus 2. I'm going to distribute that fraction and get -3/2 x. And -3/2 times 2 is -6/2, which is -3. I'm then going to add 2 to both sides. So my final equation is y is equal to -3/2 x minus 1. All right, so the point we're passing through is -2, 2, which is right here. Let's see what it looks like. I'm going to graph -3/2 x minus 1. So I'm going to start at my y-intercept of -1, and my slope is -3/2. So I'm going to go down 3 to the right 2. Okay, or I'm going to go up 3 to the left 2, and I happen to land on the point, and we just draw lines like that. We have our perpendicular lines. Okay, so that is it for today's lesson. All right, so you should have done the exit ticket, and the homework is 25B. Bye.